So let's talk about SolidWorks assemblies a little bit. And an assembly file is one of the three files you can open up with SolidWorks. That's one of those evaluation questions. First one's being a part. And now that we played with parts and have a bunch of parts under our belt here, now we can talk about assemblies and be able to put stuff together, which is really kind of fun. But the third file that you could open up with SolidWorks, of course, is a drawing file. But to think about the assemblies and drawings, is you need to have something of substance in the background in order for those two files to work. For a drawing, you kind of need to have a part in there, and with a drawing file, what you're doing is creating windows in that drawing file in order to look at the part from different views. You're going to put annotation and dimensions and stuff like that on there too, but without the part file, the drawing file fails, and the same with an assembly. Without part files in the background of the assembly is going to fail too. So you need to make sure that when you send those to me, and when you're creating an assembly file, and when somebody else will look at that you send the part files with them too. Part files go with the assembly file, and all you're doing in an assembly file is creating the architecture and how various parts kind of interact with each other. And that's all it is. So let's go ahead and go to New, and we'll go to Novice over here. We're just going to go to that second file over here, which is going to be assembly. You can double click there or just go to OK. And the first thing it wants to do is it wants to jump into a folder, and it wants you to put a part in the assembly right away, but you may not be ready for that, so let's go ahead and do this. Let's just go ahead and close that out, and then close this over too. So you'll notice it looks very similar over here. You have the command manager up here with some different functions up here. But over here in our properties manager, that should look familiar here too, and you're looking at some properties in here that we have to deal with. But we're going to go to the X over here and kind of take a look at how the assembly file is actually arranged. So starting from the top, over here is our different managers. We have our feature manager over here for feature manager design trees, named the same thing. Then you have your property manager, your configuration manager, same thing that we remember before. We have a dimension expert manager, and you have your display manager, and over here you have your display styles over here, your display pane. And we haven't talked about this a lot, but we're going to get into this a little bit more as the quarter goes on. But you can high show items over here, your display mode, whether it's shaded with edges, wireframe, and whatnot. You can take different parts in here and actually show them in a different way if you want to do that. You have your other display options in here too, including transparency and appearances. But enough of that. Let's work our way from the top down. Just like with a part file, it's looking for a name up here. We haven't named it yet. It's got a little bit different icon up here. It's got a yellow background and kind of a blue little box sitting in front of it. It's got a yellow background denoting a part, and a little blue box sitting there in the corner of that. It's just it's an icon that's implying an assembly. Two different parts coming together. And we haven't named it, so it's called Assembly 1 or Assembly 2. I've opened this twice, so now it's consecutively calling that a different name, Assembly 2. Hasn't really saved the file yet, but it's kind of a placeholder there until we actually do save it. So just like with the part file, we have the history folder, we have a sensor folder if you want to put stuff in here to make sure the parts don't rotate a certain amount or exceed a certain value. We can put in all sorts of sensors in there. We haven't talked about that, but we're going to save that for a different video. Annotations. Whenever you put in your parts in here, they have annotations that come with it, and we can modify those, and again, that's going to be saved for a different video. And look at this. We have a front plane, top plane, right plane, and the intersection of those three planes it's the origin. So very, very similar to a part file in here. One thing that's a little bit different here is this bottom folder just below the origin. In a part folder, in a part file, we don't have anything below the origin. Everything that we create is going to be created after the origin in a certain history. But now we have a mates folder, or a mates icon here. And what that does is allows us, when we put parts in here, to actually mate those together. And you'll also notice that with a lot of these mates, they're very similar to a lot of sketch relations. Parallel, coincident, collinear, corradial, stuff like that. Those are also mate options here too. So when we put our parts together, we're going to put these together, we're going to mate them together. Typically it takes 2 or 3 mates to get those together, actually make one part to actually fit with another part. Sometimes you can get away with one if you want some flexibility and have something move, like a hinge rotating. You'll probably just want to have 1 or 2 mates in order to define that. But to define all the parts that come together into an assembly, you're going to have a mates folder, and we're going to populate that as we add more parts to this. So now that we have our first part in place, one thing to note over here in our feature manager tree, let's go ahead and take our part and kind of minimize that for a bit. You'll notice that we have a bracketed F next to it, and then we have the part name after that. We also have more stuff after that too, which implies that we're looking at a configuration, the default configuration, and the default display state. But we're going to talk about that stuff a little bit later. But for now, that bracketed F actually means something. And this is another test question, another evaluation question. The first part you put into a SolidWorks assembly is automatically fixed. Not necessarily fixed at the origin. It is now that we went through the physical effort and actually putting the origins together. But the first part you drop in there. If you just dropped it arbitrarily without considering the origin or that green check mark over here in the Properties Manager, it's still going to be fixed in an arbitrary location, but the first part that you put into an assembly is always going to be fixed. And this time we fix it to the origin, which is good. So let's go ahead and save this. Let's go ahead and save this part file. It's probably a good idea to do that right now. So we're going to go ahead and call that the hammer with today's date on it. I usually put the date on it. So we're going to create a whole different file over here, and this one's got a file extension of SLD ASM for assembly, and we're just going to call that hammer and go to save. Okay, so let's insert our first part into the assembly, and remember, test question, evaluation question, you need to have a part in order for an assembly to work. So you need to have a part in there. Otherwise, you can't really create parts within this assembly. That's not easy. And we're going to cover that feature actually here in a little bit too, in a different video. But we need to insert a part. So that's what we're going to do right now. So there's a couple of ways we could do this. We can actually take a part from a file. We're going to take our hammer handle and just drop that in there like this. And it's going to put that in place. But that's one way. Another way is to go ahead and insert components. And we could do it that way too. So this is a dialog box we saw from the very beginning. And when you open up an assembly file from the very beginning, usually will kick into the folder that you were in last or some similar folder. It's going to suggest a couple different parts. So we can select it here too, or you could go to File actually you can go up here to the pull-down menu, go to Insert, and then go through the options in there too. But as long as we're here, the probably most common one is up here in the Command Manager under the Assembly tab. So over here would have been the Feature tab, but now it's the Assembly tab in the Assembly, and we're going to go ahead and insert a component. So now we're going to go in this dialog box and we're going to pick something. So we're going to pick the hammer handle, and you're probably familiar with that. And we're going to go to Open, and first thing you'll notice that with the cursor, don't do anything yet, don't click anything, but you notice that the cursor is real fluid. It's just moving around the assembly. It's actually the handle that's moving around rather than the assembly. But if we just escape once and go back over here, we're going to go to the X over here and just kind of exit out of that. What we probably want to do, just to be instructive, if we go to the origin and right click on that and actually show the origin, I think we turn that off. So we want to make sure that origin's shown over here, which it is by default. But go up here to hide show. Let's go ahead and show the origin up here. So view coordinate system, view origin is what you want. So now when we go ahead and insert components, so we could do this a little bit different. We can go to insert, and then we can go to component, which is up here at the very top, existing part in assembly. And then again it opens up that very same window. And we're going to go to hammer handle and then go to open. Again, it does the same thing here too, but now we can see where the origin is, and we can see that it's actually the handle that's moving around rather than the assembly. One thing about that origin, if you actually get close to the origin with your cursor and get really close to it, you'll notice that the origin, which is in the very back of the hammer, you can actually see it back there. It's got that blue icon to it, not red like what we would see in a part, but it's blue because we're in an assembly right now. We're not actually modeling with the origin in mind. It's just blue in the background. You can see that. So if we actually approach the origin is in the assembly, it is suggesting that we would mate the origins together, and that's actually a really good thing. If we didn't do something like that, if we didn't mate the origins together, then the part would just fall out there in an arbitrary location, which may or may not be bad, but we would have to try to define that later. So what we really want to do is we really want to put it on the origin. So that's one way of doing it. Another way of doing it is just go to the green check mark over here and it will put it on the origin there too. Notice that when we go to the green check mark and we actually leave this, it's going to put it right in the origin. So what's the importance of having it on the origin? Well, the importance of that is it's actually going to line up our plane. So we spent a lot of time building our parts with symmetry in mind, and now that we have an assembly together, we could actually continue on with that symmetry. So we know that the front plane and top plane are right here in the middle of our part. So if we actually go inside our part over here, if you look at the feature manager tree, the mates folder actually kicked down below the part. So it's very consistent what we have been used to seeing in our part files, is that whatever we put in here begins right after the origin. But this is actually the part file. If we open that up, we could actually see everything that we created with that part file. So if you look at our front plane over here, that's the front plane of our part, but if you actually look at the front plane of the assembly, which is also green, they're lined up. And that's the key about putting the origin to origin together, is that it's going to line up all the primary planes. So again, if we take the top plane and top plane and take a look at that, they're actually coincident with each other automatically. We don't have to define that later. And of course, the right plane to the right plane is going to be lined up there too. So that's the reason why you want to select the origin when you put your first part into your assembly. Okay, so let's insert one more component. We're going to make a real hammer out of this thing. A virtual hammer at least, but it's going to be a real virtual hammer. We're going to go up here to insert components. It's going to take us back to the menu there, the file location that we were in before. And this time we want to go ahead and choose what's called the hammerhead dummy. And we're going to go ahead and open that up. So when you get that selected, go to open. And we're just going to drop that in here. So you notice that the orientation's not quite what it could be. And that's okay. And it's always nice that when you put your parts together that you consider the orientation of the part ultimately when it's going to get inserted into a drawing and when it's going to get inserted into an assembly. But if it comes in something like this, that's okay. We're going to go ahead and line this up, and it gives us an opportunity to show you what you could do with a part like this. And to really make it quick, by the way, we'll cover this in a different video. If you actually design all your parts like in a multi-body model and you're using the same origin, if you just put all the parts in there, one right after another, configurations of the same part, and you put that in there and you just click to the origin, it's going to automatically go where it needs to go in the assembly, just as you set it up in a multi-body part. But again, we're going to cover that in a different video. But for now, you'll notice that we still have the origins on it, so we can see the origin of the hammerhead. And if we turn our model around, you can actually see what it's doing. And it's just like with a part. When you take your middle mouse button and move that around, you can see the whole assembly move. But how do you move just the part? So what we like to do is kind of manipulate that hammerhead a little bit so we can actually get it towards the top of our hammer handle. So one way to do that is to go up here to move components. And we could actually click on that. We can move this around. But if you go below that, you could actually rotate that component and put that in a very similar manner. So when we get really close to mating this, we can put those items together. So we can go to the green check mark here. And now we could probably line up some planes. It's always good with the symmetry that we have that we could probably line up some planes in here. So let's think about what we could do. There's our right plane on our on the assembly. But if we go to the hammer handle over here and see what planes we could deal with, we have a top plane over here, which I think is probably going to be coincident with maybe the right plane of the hammerhead over here. So if we click on both of those with the control key to press, just like in a part, it allows you to select different elements at the same time. We could actually mate those together. And what it's going to do is it's going to make those two planes coincident. If you like what we see, you can see in the background the part that's not being manipulated, but the part that is being manipulated is going to be in the foreground. It's going to be kind of a dark. It's going to be visible. And once we do that, we can go to the green check mark. Now let's just see what we did. Right now we're still in the Properties Manager. Mate selection allows us to select two different elements from two different parts or from a different part and the assembly and mate those items together. And what we just did is we took the top plane of the hammer handle and the right plane of the hammer head and actually mated those together. And we'll talk about mates here in just a little bit, but let's go to the green check mark here and see what we have. So now we have that hammerhead. It's going to be coincident with the the top plane of the hammer handle. So we have a little bit of flexibility. We can't rotate this anymore. So if you go up to move component and go to rotate component, we can rotate it this way, but now we can't rotate it about what would be the z-axis in the assembly. So we're beginning to constrain this a little bit, kind of like the sketch relations that we're familiar with in a part. Okay, so let's take a look at our feature manager over here and maybe reduce our parts a little bit. So we're just looking at the basics up here. This mate folder now, if we go ahead and open that up, we have one coincident mate. If we open that up, expand that a little bit and take a look at that. We have a mate between a hammer handle and a hammerhead dummy in here, and it doesn't tell us exactly what it is, but it is a coincident mate between the top plane and the right plane of the hammer handle and the hammerhead. And as we continue to put this model together, this assembly together, we're going to get more mates. We have a mate folder here, but we also now have a mate folder as part of the part. So if we open that up, we have that same coincident relationship in here. And you also notice that when we click on that coincident relationship in here, it actually shows us what those components are. So one's going to be orange, one's going to be purple. Purple is going to be the primary one, and the one we're trying to mate to the primary, the one that's already fixed in the model, or fully constrained or fully defined in the model, is going to be purple. So that's in that folder, but it's also in the other part here too. It's also in the hammerhead part. So again, we have the coincident relationship in here. We can rename these two. I accidentally clicked on it as if I was going to rename it. But here it is. Here's our coincident relationship in here too. And it's showing us over here in the graphics area what we're going to get. Okay, so one thing to note as we're moving through this, we're going to go ahead and mate this one more time, a couple more times actually, and we're going to fully constrain this. When we get to this RS mechanism, there are going to be some components in there that are not going to be fully defined, and they're going to have some motion to it. Specifically the hinges, the push rod, and the wheel. Those are going to have some motion capability with them. But if we look over here at our feature manager tree, we talked about that bracketed F over here, and that means it's fixed, which means it cannot be moved. Selected component is fixed and cannot be moved, as you can see next to the cursor. And when we get this fully defined, it'll say something very similar. But you also notice that we have a bracketed minus sign here. That minus sign means that it's not fully defined. So we could actually move it around. It's got some motion. We can move it back and forth. We can rotate it. Not going to be able to rotate about, it's only going to be able to rotate about the y-axis if you look at the triad down here. Because we do have a constraint on that, the top to the right plane. But yeah, let's go ahead and add another another mate in here and see if we can make this up a little bit better. One thing I would suggest doing is mating perhaps this surface here with this complementary surface over here in a hammerhead, and that'll constrain it a little bit more. And the way we do that is we can go up to the mate button up here on the assembly tab in the command manager, and we can do it that way. Gives us a blue selection box, and now we can go in here and actually select those elements. And I like this feature where the fixed elements or the fully defined elements in the background kind of get transparent, but the item that we actually want to create that relationship with remains solid, so we can actually see it. We can actually see through it and actually see in much better context what we're going to be doing here. So now we have a couple different choices. We can go over here to our feature manager, our properties manager over here, and go through some of the selections down here, including coincident, parallel, perpendicular. We can lock it in place. We can give it a distance dimension or even an angle dimension in here too. We're not going to go through all these options in here, but you also get the shortcut menu out here in your graphics area too, which give you the same thing. We can select some of these, like parallel is just going to make it parallel, which means we're going to be able to move that thing back and forth still. Perpendicular is going to flip that around. Lock is going to kind of lock that in place, considering this reference over here, the two references that we selected, kind of like fixed in a sketch environment. So you'll notice that a lot of these constraints that we have in here are very, very similar to what we've seen when we're sketching in parts. We could put a distance relationship on that. Perhaps we want to make that maybe an inch away, and we can flip that dimension too if we want to do that. So there's that option. We can make an angle to it, maybe 20 degrees perhaps, 30 degrees, flip that around too, and so on and so forth. But let's do what we really want here, and that's going to be make a coincident. We're going to make that coincident, and we're going to go to the green check mark. So back to our model, you'll notice that as we're putting this together that we still have, once we define the mate, that the mate properties manager is still open over here, expecting us to select more items. And that's typical, because typically when you put in parts into an assembly, it's you're going to be choosing more than one mate in order to get this together. So at least two, sometimes three or four, in order to get this all put together. So that's going to stay open, but for us we're going to go ahead and close that for now and take a look at our model a little bit better over here in the graphics area. So you'll notice that if we go to Move Component, move that down, go to the down arrow, and actually go to the Rotate component and see what we can do here. We can't really rotate that. It's kind of constrained by the two constraints that we have in here. But we can still move it. If you go into Graphics area and move that around, you notice that the hammer will actually go through solids in here. So again, you kind of have to think about this. We're not in a physical world here, we're in a virtual world, so SolidWorks is allowing us to do that. But there are ways, and we'll cover this a little bit later, there are ways where you can physically constrain this. So when it actually runs into something, it'll alert you. Or if you're actually physically interfering with something, it'll block you, and it'll keep you from going any further on that. But let's do this. Let's consider about what we're going to be doing in order to get this fully defined. So as we pull this down, you can see that if we made some sort of relationship perhaps between this line and this surface over here, or if we pull this out a little bit, if we're going to make a relationship between maybe this surface and maybe a line up here, this is not necessarily a flat surface. It's not going to be parallel to that surface down here. So we're going to have to be careful about that. But if we go between line and that surface, we could actually define it there too. So let's try that. This time we're going to do this a little bit different. We're actually going to pick the noun first and then the verb second. We're going to pick that object over here in the modeling area, in our graphics area, and then maybe this line over here with the control key to press. And then if we go up here to mate on the assembly tab in our command manager and put that together, initially it's going to make that coincident here, but we may not want it to be coincident because it really buries itself into the handle a little bit. So if we actually maybe pull that out a little bit, we can go down here to distance. Right now it's kind of arbitrarily, but before we initiated a command at about 3 inches. But maybe if we made that maybe 1/4 of an inch, that puts us pretty close over there. Wow, it looks like it puts it right on top of that. Don't necessarily want to put it on top of that, so maybe 0.1 inches from the top. Oop, that digs it in, going in the wrong direction. So maybe 0.375. And that puts it into place. So if we like that, maybe a little bit more than that, maybe 0.3 would be a better choice. That way it puts it down there pretty far. And of course what we're looking at here is we want to give ourselves enough room up here in order to put the wedge in here. And I believe the top of the hammer that I was modeling actually has some sort of resin in the top here, in the top of the hammer too, on top of the hammer head, in order to maybe solidify that a little bit better. But once you have that in place, if you like what you're looking at, go to the green check mark. Now we're ready to go. So let's check our model. You'll notice that we have, again, part of the virtual model. It kind of sticks out here a little bit. Not quite right. And this gives us an opportunity, if we didn't measure things correctly when we put our two parts together, that we can actually go back to the parts now that we put it together into an assembly, and make our modifications. But let's go ahead and go to the green check mark, or X in regard to the mate. And let's go ahead and tug at that hammerhead, and now you'll see a different message. It says the selected component is fully defined, it cannot be moved. The item that's fixed says the selected component is fixed and cannot be moved. So that gives you an indication that it's fully defined. If you go over here to Feature Manager, we no longer have that bracketed minus sign. And of course, just like with sketches, we could actually have a bracketed plus sign there too, which means it's overdefined. We put in too many constraints. So the next step we're going to do is we're going to go ahead and trim out our hammer handle a little bit in order to make sure that it fits inside of our hammer head. Okay, so we kind of need to fix the handle here. So what's a good place to start? If we rotate the model around, you can see where we have clearance. We have definitely clearance, a 1/2 inch clearance from either side. But our 1 inch handle and depth over here isn't quite fitting inside of that. So how much of a correction do we need to make? One way to do that is introduce you to a new tool on the Evaluate toolbar. If we were to go up to the Measure, go to the Evaluate tab up here, and then go to Measure, we could actually measure between a couple different surfaces. Let's go ahead and move that dialog box off to the side. If we click on this surface over here, and this surface over here, it will tell us what the distance is between those two surfaces on the hammerhead, which looks like it'd be about 7/8 of an inch. So what do? There's a couple things we could do. There's a number of things we could do, but I'm going to show you two of them. One thing is we could just right-click on that hammer and we can tell it to open it. We're opening up the hammer handle, and now we need to make our corrections to this. So if we were to take the rollback bar back to the point where that piece is, and I think what we did is we created that handle end over there, and then we made a cut on that. So it's this cut over here that we want to make a modification to. So if you were to right-click on that cut, go to Edit Sketch. Nope, not that one. Let's go to the next one. So actually, let's go to this one, handle end cut. Let's go to the sketch in that one. That's what we want. Okay, so it's right now at 1/2 inch by 1 inch. If we were to make that point 875, 7/8 of an inch, it makes it a little bit shorter. If we go ahead and rebuild that, now we can see what that's going to do. And if we were to take our rollback bar and roll it to the end, if you have any errors, now is probably a chance to correct those errors. But it looks like everything's building correctly. Let's go back to our model. If we did Control and Tab keys consecutively right after another, it takes us back to the model. And if we want to rebuild that, it gives us an opportunity to do so. And well, if you wait too long, it's going to do it for you. But as you saw, maybe initially you saw a little bit of a distortion over here where some of the handle was sticking out up here. But as we rebuilt the model, now it fits inside of that, which is really good. So, one more modification we need to make. If you take a look at this over here, you notice that it looks like a bit of the hammer, the corner of the hammer handle over here is kind of digging into the metal, or vice versa. You notice that we do have a radius on this thing, a fillet radius, that probably should be employed to the hammer handle. So another way of making modifications to your models, to your parts within the assembly, is just take the part itself. If you were to click on that part and go over here to Assembly and go to Edit Component, it allows you to do all your editing within the component itself. So everything that's not going to be edited sits in the background, kind of transparent. You'll notice it over here in the Feature Manager tree, that in the Assembly Feature Manager tree, and we now have the part, and it's in blue. All the elements in that Feature Manager tree are blue. All the text that defines all the sketches and the features that we have in there, and it gives us the capacity to add more stuff to it. So we can go up here now that we're in Edit Component. We have the capacity to go into Features. You'll notice that we have all the different options that we had before in regard to putting a part together. We also have a Sketch toolbar or a Sketch tab up here too in our Command Manager. But what we're looking for over here is going to be our fillet. So if we're to click on Fillet, we're going to go ahead and click on a couple edges over here. We're going to go ahead and click on this edge over here. And I think our radius is going to be, boy, that's really big. I think it's going to be 0.06. So I think that'll probably bring it down. We're going to go ahead and verify that in a moment. We're going to go ahead and click on 4 edges in here and do that. Here you notice that we have all the capabilities we had before in regard to editing our part. If we were to take a look at this maybe from the very top up here and see if it actually closely conforms to our fillet that we have in the hammerhead, which is pretty close. I think the fillet on the hammerhead might be a little bit different. It looks like it's a little bit off, but we can verify that when we get back to the assembly. Go to the green check mark here. You'll have to do this one more time. We're going to have to go up here to Edit Component to get us out of that. And once we do that, it gets us out of being able to edit that part and puts us back into the assembly. So now if we take a look at this, it looks like it conforms actually pretty well. It looks like it conforms right on or pretty darn close. So that's how you put in your components in here. Remember, our first component in here was a fixed component. It's going to be the hammer handle. And we put in the hammerhead, and we had a lot of flexibility with the hammerhead when we put that in there. And in regard to the hammer handle, remember when we put that in there, it becomes fixed. We made it fixed to the origin, but the hammerhead was not. Had a lot of flexibility with that. And with 3 more constraints, we went ahead and put that hammerhead on top of the hammer itself, on top of the hammer handle itself, in order to create the hammer. And then we went ahead and made modifications to it. One of the modifications was to take the part and edit that outside of the assembly. The other modification we made to the fillet radius on top of the hammer handle, we were able to make that modification within the assembly itself. So one last thing, let's go ahead and turn off our origins in here. And now we have our hammer.